Distillations. On January 24th, 1978, something very unusual happened in the wilderness of Canada's Northwest Territories. Residents of Yellowknife, the closest city, were pretty confused.
When I first saw it, I thought it was a jet leaving the airport, and then I realized that it couldn't be a jet because it had this long, fiery flame following it. And I thought, well, it might be a jet that was on fire, and then, like I said, I realized it wasn't because the part which I thought was a jet was like a fluorescent light. The whole thing was so
Really?
bright. And I called my son and daughter, who were just coming out of the door, to look at it. And we saw this thing passed over us. Dozens and dozens of pieces following it, and they all had tails, long, fiery tails.
The next day, it was clear what had actually happened. This is Jim Lehrer from the McNeil-Lehrer Report on PBS.
Good evening. Something scary happened yesterday, something science fiction buffs have been telling us for years was going to happen. A satellite with a nuclear reactor aboard fell out of the sky. The damage was apparently more psychic than physical. The Russian craft, known as Cosmos 954, re-entered the atmosphere over the wildest country of Canada's Northwest Territories, all of it disintegrating into magnificent but harmless balls of fire before anything hit the ground.
American intelligence officials had been tracking Cosmos 954 in orbit since December of 1977, and they'd noticed it was acting erratically. Actually, it was completely out of control, which was concerning, of course, because it was powered by a nuclear reactor. What would happen if this thing landed on Earth? Would it cause radioactive fallout? And how would we know where it would land? U.S. intelligence warned the Canadian government, but neither government told their citizens about the threat. The Cosmos 954 saga brought residents of Canada's Northwest Territories into the space age, but not in any way that was beneficial to them. No, they got acquainted with outer space through the trash that space exploration creates. They got to know space junk.
The space age became truly global, not through moments of innovation, of technological innovation, but in moments of decay.
I'm Lisa Berry-Drago, and this is Distillations. On this episode, we're talking to Lisa Ruth Rand. She's a research fellow at the Science History Institute and a historian of science, technology, and the environment. We're going to talk about her book in progress, Space Junk, A History of Waste in Orbit. And we're going to find out what space junk tells us about our relationship to outer space. Who has ownership over space? And what are those people leaving behind there? So thank you so much for being here today.
Happy to be here.
So first, what is space junk?
Well, space junk, like any other trash, any other waste, is really kind of contingent on the eye of the beholder. So what's one person's trash is another person's treasure applies in outer space the same as it applies on the surface of the Earth. In NASA and other state space programs, the general definition of space junk, or orbital debris, which is its more technical name, is any object designed for use in outer space that currently does not serve a designated purpose. And that can refer to objects that are still in space and objects that have fallen through the atmosphere back to Earth.
Could you just really briefly give me an idea of what are the types of things that are up there in space? What quote unquote waste have we left behind?
A lot of things fall under that umbrella. There's everything from satellites that are no longer operating, pieces of rockets that launched those satellites that are no longer that didn't re-enter the atmosphere that are still up there, objects shed from rockets and satellites. There's also stuff that astronauts have left behind. For example, astronauts on the moon left behind garbage bags. Every moon mission left behind a garbage bag.
Wait a minute, a garbage bag of what?
Well, they contained everything from food wrappers to unneeded devices to likely human waste. So there's poop up on the moon that will outlive us all. Yeah.
I'm so glad to hear you say that there's poop on the moon.
Well, they left cameras up there too, because it was just, you have to be careful. Weight is always a consideration. So all the cameras that they used to take pictures on the moon they took the film out, but then they left the cameras behind. And then one Apollo mission actually threw one of these garbage bags out on the way back, and that is likely in a solar orbit at this point. It's not being tracked. We don't know where it is. But yeah, they opened the door, threw it out, and said, "Bye-bye, bag." It's in the
Wow.
transcripts.
That's
So-
amazingly reflective of the attitude that we have towards space.
Well, it's not only that; it's more just the attitude we have towards our wastes, right? When we discard things, it's we are taking something we don't want and putting it out of our vicinity. And it's rare that it then actually disappears. It becomes someone else's problem, or it gets taken up by another, taken up by the environment and moved to places where we don't expect it to move. But our atmosphere does protect us from a lot of the bombardment. That said, if these anti-satellite tests happen and debris hits other debris, hits functioning satellites, and suddenly you have what's known as the Kessler syndrome, so a kind of a chain reaction, domino effect, where suddenly we no longer have use of orbit for satellites, that would be a major problem. This is something that I think is a very important part of thinking about space junk as an environmental problem, is that it's ultimately, we're talking about an infrastructure. An infrastructure is a technological system that provides the backbone for multiple other practices, and that's invisible. It becomes naturalized. It's invisible until it fails. So we don't think about the electricity until the lights go off. We don't think about the sewage system until our toilets back up. We won't necessarily think about our satellite information infrastructure until we can't use it.
Right.
Because then suddenly you realize how much of what you and I do on a day-to-day basis is attached to satellites, whether it's using a GPS on our phone, whether it's taking money out of an ATM, whether it's using the internet, whether it's making phone calls, whether it's flying on an airplane, whether it's any sort of financial transaction is in many ways usually attached to satellites. With, any sort of live media, our global modern world is supported by satellites. And if those were to go away, it wouldn't be something that we would see or notice within in any way that we would if it's any other sort of infrastructure that we think of on
Right.
Earth.
If a bridge collapses, you understand.
You notice it.
Yeah. You probably understand it before it's happening. You understand, this is crumbling, 1970s infrastructure. We need to strengthen this. There's been some work done. There's this crisis. You see the before, the during, the after kind of. But a satellite communications blackout globally would be catastrophic, and
but you wouldn't necessarily, it wouldn't feel catastrophic. You would just notice that things aren't working the way that they're supposed to. I like to think of it as you would feel in your body that something was different. Why are all of these kind of cyborg practices that you're so used to not working? And it's because one critical piece of that infrastructure is gone. So that is kind of why I think this discussion needs to be bigger, and why everyone should care about space junk. Everyone who participates in industrialized society, anyone who has a smartphone, anyone who consults weather reports, anyone who wants to be rescued in the case of a natural disaster or humanitarian disaster, any number of things that we rely upon. I mean, our defense communities are completely reliant on space infrastructure to operate. It's so deeply integrated into everything, but yet so invisible to the majority of users of satellites.
There's more stuff being sent up year after year. And some of that is happening with private companies, like with SpaceX. SpaceX is the one that keeps coming up again and again. So I'm curious what there is to say about the Starlink satellite launches to create new, faster internet connections, supposedly. And first of all, what is Starlink? We'll start there.
Starlink is a so-called constellation of satellites. So a cluster of many, many, many hundreds, ultimately at the end, if not thousands of satellites that together are designed to provide broadband internet access across the world, including in places where traditional broadband have either it's difficult to connect people or they just don't have access for multiple reasons beyond the material feasibility. So in many ways, it's kind of a noble idea, and one that kind of relates to this idea of access to space being something that is ultimately limited by access, or by wealth and capital and resources. But it's been kind of tricky in many ways, partly because this is something that's being launched by a private company. And Elon Musk, who's the head of SpaceX, has announced that he wants to launch 2 Starlink launches per month in 2020. And now each of these launches has several dozen satellites within each rocket. And so there have been 242 Starlink satellites total launched as of the end of January 2020. And this is an exponential rise in the total number of artificial satellites in orbit around the planet. And when Starlink first started launching, astronomers in particular were very, very concerned, and their responses were remarkably similar to the responses that astronomers had back in the early 1960s when they were concerned about the first communication satellites. They were concerned about setting a dangerous precedent. What would happen if exponentially more shiny objects were launched into outer space? Because each one of these satellites has a large shiny surface area, and it reflects sunlight at dawn and dusk when the satellite itself is against a dark sky, but the sun's light is still coming around the horizon. So particularly when the objects are first launched, they're at a lower orbit, they can really crowd up your field of view with artificial shiny things. There's also, of course, concern about radio spectrum use, which is also a long-term concern among astronomers about how to protect their ability to observe in multiple wavelengths, not just optical, but also radio. And then, of course, there's also the concern about what happens when things break, right? So Elon Musk has made very clear in response to these concerns that the original satellites will be designed to re-enter quickly so that any detrimental effects would be short-lived. This is something that is verbatim the same as, in particular, one early space communications project called Project Westford. That was one of the first real communication satellites that astronomers were concerned about what would happen if they stayed up forever. They were assured by the U.S. Air Force and the MIT Lincoln Laboratory that they would come back to Earth and that any potentially detrimental effects would be short-lived. So you're seeing a lot of the same argument, the same protest, the same resistance back from the designers to this question of who gets to put what up there and what's at risk, what's at stake. And the big difference here is that unlike with Westford and with these early space programs, instead of it being a state power, it's an individual, it's a company that don't answer to the same powers as state actors. SpaceX does not receive, indirectly they receive taxpayer money, but they are not funded directly by the taxpayers. They don't have the same accountability. They don't have the same bureaucracy. So there's a lot of big question marks and a lot of the same kind of recurring, rhyming debates going on that have been going on since the very beginning of the space age, but just of a different shape as the actors change.
So you mentioned Project Westford in relationship to the Starlink. Could you tell us a little bit more about that?
Sure. So Project Westford, which was originally known as Project Needles, was a passive communication satellite system that was developed by the MIT Lincoln Laboratory beginning in around 1958, and then they did 2 test launches of it, one in 1961 and one in 1963. And keep in mind that during this time period, we had very few artificial satellites to begin with, and when Project Needles, as it was initially called, went into development, we really didn't have anything that you could describe as a communications satellite. None of the first few satellites could actually transmit a satellite from one point on the ground to the other point on the ground. And what the MIT Lincoln Laboratory was trying to do was to try to figure out if there was a way to use multiple tiny satellites to use as reflectors for signals sent from the ground. So Project Needles was something that would not be recognizable to you or I as a satellite. So the space-based components of the project were these tiny copper fibers called dipoles, which were thinner than a human hair and only a couple of centimeters long each. But there were some 400 million of them that were to be launched to an altitude of about 3,500 kilometers. And together as an aggregate, they could serve as a kind of artificial ionosphere. So the ionosphere is part of the atmosphere where there are a lot of charged ionized particles that we use to reflect radio waves across long distances, over the horizon in particular, where you can't just do a straight line of sight. But also during this time period, both the United States and the Soviet Union were launching space nukes, basically. They were exploding nuclear weapons in outer space. And that had the effect of temporarily disrupting the ionosphere and making it so that any land area under the explosion could not communicate out using radio. So by creating a kind of artificial ionosphere much higher into outer space, much higher than any exoatmospheric nuke could fly, Project Needles would provide kind of an important communications infrastructure that did not yet exist. However, the Lincoln Laboratory, as it was developing it, grew a little concerned that perhaps astronomers might have some concerns about the way that the project was being developed, because there were going to be these 400 million shiny copper fibers in space that were not there before. And so they made certain aspects public. They enrolled the Space Science Board of the National Academy of Sciences to evaluate it. There was a lot of back and forth. There was a lot of resistance within the Space Science Board, but eventually, when details were made public through an astronomy journal, astronomers around the world really responded negatively. They were not so much concerned about the test project itself, though they were concerned about it. What they were concerned about was, what if this became the norm? Now, when we think of satellites, we think of these large behemoths that have lots of electronics on board, that can accept, store, and amplify a signal back to another point on the ground. In many ways, this was kind of an interesting, cheap way to have the same process, maybe not as high fidelity or as high quality transmissions, but a microwave signal sent from one point on the ground to this belt of dipoles would then be scattered by those dipoles and picked up by a receiver on another point on the ground. So everything in space could be very easily, cheaply installed. This is just copper. It's not a very fancy or unusual substance. Not a very complicated design, one that could be cheaply and quickly installed at a moment's notice if needed, and one that would provide the military with communications backup if, say, space nukes become part of warfare, right? Become something where you can create an effective blackout over, say, Washington, D.C. without actually destroying anything on the ground, but suddenly the president can't communicate with his nuclear arsenal around the world, especially if that's in conjunction with cutting transoceanic cables. So they were concerned about what would happen if this became the norm. If this was just a test version, a more fully functional version would have multiple belts, would have one around the equator, one around the poles, and would be denser, have many, many more dipoles. And then what if the Soviet Union wanted their own dipole belts? What if Europe wanted their own dipole belts? And suddenly you have a sky full of reflective material. Now, why did this matter to them? Optical astronomers were worried that having all this reflective material in the sky, much like their concerns about Starlink now, would create a lot of visual noise. So lots of little points of light that were not naturally occurring, that were just human-made artifacts. There were a lot of optical astronomers who were also concerned about a collision hazard. So during the same time period, the very first orbiting astronomical observatories were being developed. And many astronomers were very excited about this prospect because the atmosphere filters out a lot of the electromagnetic spectrum that we can't observe from the ground. By placing a satellite above, by placing a sensor above the atmosphere, suddenly you have access to gamma ray radiation, you have access to X-ray wavelengths, you have access to ultraviolet, all these different wavelengths that we couldn't observe with before because of the atmosphere. There might be this revolution at stake, but what happens if suddenly you have all of these dipoles that the Space Telescope is lower than, and then you're going to have to put the Space Telescope even higher, which is riskier and more expensive. Right. Or you have it in the same area, and then you have collision hazards.
For a project like this to have been one of the first big launches, I can see a lot of concern, because of course here we are now. Like, they were right to be concerned.
Right. And Westford was not the only one that astronomers were concerned about. Anything that was large and shiny, any satellite really was something that they were concerned about. But this was one that gained a lot of traction. And it got a lot of press. And one of the things that I found really interesting in tracing how that project changed and how different communities responded to it was that the first test launch, which failed to deploy the dipoles as planned, was in 1961. The second was in 1963, and the dipoles did successfully deploy. And in the middle, 1962, was the publication of Silent Spring, which really kind of changed the way that mainstream communities thought about pollution, thought about what counts as pollution, and even thinking about pollution that's invisible. And what's been so fascinating to me as I research astronomers' protests against these early communication satellites is that they're using really proto-environmentalist terminology to describe what they're concerned about. They refer to creating a space pollution control board staffed by astronomers to try to make sure that outer space can be protected from destruction at the hands of these kind of faceless state authorities that are otherwise acting with impunity and without consent. This is all really in the moment right before and during the publication of Silent Spring, the rise of mainstream environmentalism. So in many ways, the Western culture was really primed to talk about invisible pollution like space junk, like nuclear fallout, like pesticides. They're all kind of one and the same. Space junk really was part of that, really from a very, very early stage, part of kind of a larger conversation about environmental protection and really and about authority. Who has the right to pollute an environment, especially one like space, which is supposed to be the domain of all humankind. And the ways that that particularly journalists discussed Westford, I found a lot of op-eds that talk about the need to keep governments from polluting outer space, from littering orbit, from cluttering up space, right? So it almost sounds like just, like throwing a can on the side of the road, but with copper needles in space. And even as astronomers ultimately had stood down, most astronomers by the second launch stood down, were less concerned because of bureaucracy, because of having some reception within the people within the groups who were developing it. There were some safeguards put in. The project, as it was tested, had no real effect on astronomy. Most astronomers were satisfied that it would be okay, that Project Westford would not impede astronomical observation. That said, it also wasn't repeated. Westford was the only one of its kind, and active satellites really became the norm. The satellites that we think of, that you and I think of now. But this is where Starlink is kind of an interesting case, because, you have the stakes have changed, but the debate is very, very similar.
How does this typically work? How does space junk enter space, and how does it come back down? What is actually the mechanics of that process?
So there's multiple ways that space junk can be created and how it gets up there. Now, how it comes down is, I think, one of the most interesting parts. We often think of space as being a void, a place of nothingness. There's no air, there's no land to speak of, there's no life, and yet I like to refer to it as an abiotic ecosystem, as a kind of geophysical landscape. It's a place, the regions just outside of our atmosphere. First of all, there's really no clear cutoff between where the Earth's atmosphere ends and where space begins. Atmospheric particles extend hundreds of thousands of kilometers out into space, and this is something that was kind of an interesting revision to our understanding of Earth's place in the solar system that came about with the first satellites. When physicists were measuring how the first objects in space were moving, they realized that instead of being this physically isolated planet, that Earth had a lot of interactions with the solar system, especially the sun. So the sun sends out radiation, it sends out plasmas. There's rocky bodies, naturally occurring rocky bodies coming in and out of our vicinity. There's magnetism generated by the Earth. There's all these different interacting forces and material objects that move throughout this space, and they all interact with the objects that we put up there. So
space is a little crowded.
Space is crowded, both with things and with forces.
Yeah, it's certainly energetic.
It's very energetic.
We think of it not having wind and not having currents and not having other things that we're familiar with in air and water, but it does have the tug. It does have the push and pull and the back and forth going on as well.
Yes, it does. And the sun plays a huge role in shaping that landscape. We shape it by putting things into it, but the sun has a very, very strong force in shaping what stays up and what comes down. The sun undergoes a pretty regular 11-year solar cycle, wherein it sends out more or less energy depending on where it is in that cycle. And during periods of what's called solar maximum, the sun sends out exponentially higher amounts of radiation and energy. And during those times, it heats up the Earth's atmosphere, which causes it to expand. And because of that expansion, atmospheric particles interact with objects that are no longer being controlled and exerts friction on them and drag, and they get pulled back into the atmosphere. So that's something that's that's a natural process. The sun and Earth together interact to create this self-cleaning mechanism for orbit that sweeps clean a lot of our messes at lower orbits. Higher orbits, that's less efficient because the atmospheric particle density is lower. So I mean, kind of like a river or an ocean that can carry, that we count on to clean up our messes for us, space does the same thing. Although apparently anthropogenic climate change is causing that mechanism to be reduced in efficiency. So we think of it as being very specific to the Earth, but it extends well beyond what we think of as being the biosphere, the effects of climate change.
What you're describing feels like a solar tide in a way, where you see things carried in or carried out.
I like that, a solar tide. I hadn't thought of it that way. I like that. Yeah.
But I'm just thinking about like things that are left behind in a, like the cleanliness of a beach or the sort of visible cleanliness or the perceived cleanliness of a beach can be dependent on what the tide brings in, what the tide takes out.
Right. I think that's a very good way of thinking about it. Yeah. So, and of course, in some ways it's almost the reverse though, because when the sun drags things back in, that's when they become visible to us again.
So we've talked about the very smallest satellites. How about a really enormous satellite that did so? The needles came back to Earth, but also so did the cosmos.
When you put it that way, it sounds like the sky is falling, which is kind of how it felt in a lot of cases when large satellites began to fall in the 70s. So I mentioned the solar cycle, that the sun sends out more and less energy depending on where it is in that 11-year period. Now, the very first solar maximum of the space age was at the very beginning, right around 57 to 59 or so. And it was a very active solar maximum. There was lots of energy coming from the sun and hitting the Earth, but we didn't have that many satellites up there. So we didn't really know what the effects might be necessarily.
And we almost didn't know whether or not it was just our own fault.
Right. We just have a lot of data, right?
Yeah.
But by the late 70s, when a solar maximum hit, satellites themselves had changed shape. So the United States and the Soviet Union had sent up much larger satellites, newly massive satellites, but also satellites that had nuclear materials on board, nuclear-powered satellites. And kind of the first really big example of that was when a Soviet satellite called Cosmos 954 fell to Earth over the Canadian Arctic in 1978.
Good evening. Something scary happened yesterday, something science fiction buffs have been telling us for years was going to happen. A satellite with a nuclear reactor aboard fell out of the sky. The damage was apparently more psychic than physical. The Russian craft, known as Cosmos 954, re-entered the atmosphere over the wildest country of Canada's Northwest Territories, all of it disintegrating into magnificent but harmless balls of fire before anything hit the ground.
The President of the United States phoned me sometime around 7 o'clock this morning, said that they had it in their radar and that it was about to land, and indicated where he thought the landing would be.
The American trackers were following it, saw that it started to behave erratically shortly after it launched. They didn't know much about it because the Soviet Union was notoriously tight-lipped about everything, but especially about their space technology. So based on older intelligence, they were able to kind of assume that it had a nuclear reactor on board. And eventually, the Kremlin admitted that it did have a nuclear reactor on board, but that it had been designed to eject the reactor further into space if something went wrong. That did not happen. So again, things break in space. In the case of Cosmos 954, multiple things broke. And as the satellite's orbit decayed with the reactor on board, there was kind of a flurry of activity of concern. There were some state intelligence officials who were worried that it might detonate upon hitting the atmosphere like a nuclear weapon. It did not. The Soviet Union was very clear that it wouldn't, and luckily it didn't. But it fell into this region of the Arctic commonly known as the Barrens, which is described as a place where it's very, very cold. It's permafrost. There's ice. This is the middle of January, so there's one piece that described it as a place where flora and fauna must be tough to survive. And when the remains of Cosmos 954 fell to Earth, it fell into this region, and a lot of reporting in Canadian and American newspapers described it as being fortunate that it didn't fall in a place where there was much life, particularly human life.
There doesn't seem to be concern at the moment. I shouldn't say not concern, any danger of, or great danger of effects on people. It's an uninhabited area.
Now, this was false.
I was going to say, I bet that's not true.
Of course it was false. There were multiple indigenous communities that lived in that area and that relied upon the water and foodways of that region for subsistence. but they were largely erased from that broader cultural narrative about what happened with Cosmos 954. And at the same time, were also roped into negotiations of who would pay for the cleanup when Canada filed a claim under the Liability Convention of 1972, which is the only time it's really been fully executed, against the Soviet Union. So they were kind of erased from the larger story, this like, at least everything's fine, everything's safe.
Thank goodness that it only fell in a place that our larger governments don't care about.
Right, or where brown people live, basically.
Right.
So, I mean, even if you compare, so it fell, the closest city it fell near was Yellowknife, which is the Northwest Territories capital. And the reactions among the predominantly white citizens of Yellowknife versus reactions among Dene and Inuit communities were markedly different. Yellowknife citizens were kind of macabre humorous about it. They put one person designed a T-shirt that had a crow riding the satellite, waving his toque in the air, kind of like Dr. Strangelove. There was someone who put on their restaurant that put on their menu the Cosmos 954 burger that was a fish burger because something was fishy about why they weren't really told ahead of time about what was happening. So they thought it was funny and like everything's fine.
They're all wearing these T-shirts of like, I survived the Cosmos.
Exactly.
954.
Whereas, the officials that held kind of public information, they did attempt to hold public information meetings, but public information meetings that were held in communities that were predominantly Inuit and Dene had much higher attendance ratings relative to their populations, and those communities were extremely concerned about their exposure to radiation from this satellite. And there were problems of translation. How do you translate this danger into the indigenous languages that in some cases, according to their leaders, did not have words to describe satellite, nuclear reactor, etc. So there were a lot of challenges involved, but a lot of erasure as well. And ultimately, it was a long period of cleanup, but in the end, the indigenous communities living in the area were reassured that they were not going to have any exposure to high levels of radioactivity. But a lot of the materials that came out of that satellite remain in the environment because a lot of it was particulate. A lot of it kind of got absorbed by the permafrost, got absorbed by lake beds.
Was there a cleanup?
There was a cleanup. It was called Operation Morning Light. It was a joint Canadian-American effort to locate, identify, and contain the radioactive pieces of Cosmos 954's wreckage. And they were really thwarted a lot by the Arctic environment. They had to do a break for the spring thaw. It was very hard for them to keep their radiation monitors from working in the extreme cold. And it was a very, very complicated process, and one that was also complicated in filing for liability claims because they had to kind of wrap it up within a year in order to meet the statute of limitations in order to file a claim. So it was ultimately they did contain quite a bit of highly radioactive material. But a lot of it was they just kind of assumed would be absorbed by the lake beds and the permafrost, and therefore kept isolated from the local foodways. But the indigenous communities that were concerned about if it gets absorbed by lichen, that then get eaten by caribou, that we then eat, or if it's in the lake beds, is it going to get into the water? Can we digest it that way? And the American and Canadian test groups did conduct testing. They concluded that the particulate matter was not soluble, so that it shouldn't be something that could be ingestible. And yet, I think one of the really interesting arguments that were made by citizens of the area was, would the reaction have been different if this satellite had fallen over Quebec, over a city, over Toronto?
Right.
Would this have been different if it was a place with a much larger population, particularly a white population, lived? And
would it have been okay to leave any particulate in those environments? Would it have been considered, nature will probably absorb it. We assume a lot. As you've said about, air and sky being these like kind of boundless places that we can dump things into. And as long as it's not too much, it's probably fine.
And ice too. Ice is part of that as well. But as the ice kind of starts to recede and gives up the things it swallowed on our behalf, that is kind of turning on its head in a lot of ways.
Well, and I'm struck again by the importance of something like Silent Spring to this entire question and problem, which is that that space junk is, in a way, in many ways, it's unlike other forms of pollution, but in many ways, it manifests like other forms of pollution. Communities that are affected by it are not equally. Space junk is not much like pollution. Space junk is not an equally distributed problem either.
It is not. And it's what we would now call kind of an environmental justice issue. So particularly with re-entering objects like Cosmos 954, by quirk of which orbits we tend to use the most, and by quirk of the geophysical landscape of orbit, the majority of objects that re-enter the atmosphere without uncontrolled re-entries tend to fall over regions of the global south or the north, which is where so basically in regions where people don't as proportionally benefit from using the satellite infrastructure that has this co-located wave system, but they suffer from a higher level of risk.
Right.
So like other environmental issues of environmental equality, environmental justice, space has really shows a lot of the same attributes.
They're getting few of the perks and almost all of the feedback.
Right. So none of the people in the crash zone of Cosmos 954 were really benefiting from the satellite infrastructure. What I argue in the book is that they were really kind of brought into the space age in many ways, not through use of an innovative technology and benefiting from the use of an innovative technology, but rather through an encounter with the decay of that infrastructure, of the decay of those technologies. And this is something that's throughout the space age, that multiple communities become involved, become spacefaring, become part of the space age, not through using satellites, but through encounters with space junk.
So I know that there's another, in the same kind of solar cycle that Cosmos has brought down, there's another large-scale piece of quote-unquote space junk that falls to Earth, Skylab.
So that was arguably the most famous and kind of enduring story of space junk reentry. That was in 1979. Skylab was the very first American space station, so a crewed spacecraft that stays on orbit for long periods of time. They had 3 crews visit it, and the hope was that the space shuttle would be developed in time to dock with Skylab, rendezvous with it, and push it to a higher orbit so that it could stay up for longer. However, the
things
shuttle,
break in space.
What's that?
Things break in space.
Mainly the shuttle was delayed in its development, and the solar maximum was stronger than expected, and so it pushed Skylab back into orbit before we could rescue it. And because it was so massive, it was a very, very large spacecraft, and arguably possibly because it was a slow news cycle, it became kind of a worldwide phenomenon, people kind of worrying about where it was going to fall.
So how is it that 70 tons of space technology, an object as big as a locomotive, is floating around in space out of control and about to make a fiery return to the Earth that launched it 6 years ago?
Publicly, America's space agency says there is only a very remote chance of Skylab crashing into a heavily populated area. But privately, some of the space agency officials are worried. At least one NASA official has resigned over the way that the United States has handled the disintegration of this, its largest satellite. The space station, which is about as big as a 3-bedroom house, is in a crisscrossing orbit over 90% of the world's population, including Australia. Skylab will be travelling around 340 miles an hour, spreading wreckage over a corridor 100 miles wide and 4,000 miles long.
There's kind of a great bunch of kind of ephemera pop culture materials where, tinfoil helmets, shirts with targets on them, Skylab hit here. Ultimately, Skylab broke into pieces and fell into kind of a rural part of Australia. And large pieces were recovered. Nobody was hurt. So ultimately, though, Skylab was really kind of a really big moment in bringing the risks of reentry to a larger mainstream audience. Even though Cosmos 954 preceded it relatively recently, it was only a year before, that was one that kind of became the moment that people remember when they think of reentries was Skylab.
Was there anything to do with the sheer size of it?
Yes.
Did it generate like a particularly inordinate amount of waste?
So, I mean, the larger something is, and if it's not designed to disintegrate, right, it's more likely that pieces of it will survive. Now, it didn't survive in its totality. Unless something has adequate heat shielding, that's not going to happen. So Skylab did not have heat shielding. It was not intended to re-enter the atmosphere. So when it did, it was subjected to all that heat and friction and pressure, and it broke into pieces. Several large pieces did survive. They were charred, they were broken up, but they did survive because it was just so massive that, unlike smaller objects which can dissipate fully in the atmosphere to the point where they're kind of undetectable, Skylab did not.
I think one of the questions that I have thinking about all this is, what if we're going to keep putting things up in space, if we're going to keep sending people, machines, technology up, what are the ways, A, that's an assumption that we're going to keep doing it. Should we keep doing it? And B, are there ways of reducing the amount of junk that remains in the atmosphere and then comes back down? I think that one of the things I've heard about is sort of the reusable rocket idea.
Yes, and that's something that SpaceX is becoming well known for, but also Jeff Bezos's Blue Origin is the name of his company. They're also built a reusable rocket, but that's meant for space tourism versus satellite launches, which is what SpaceX is doing, and also human crew as well. So, yes, creating a reusable rocket means that there's at least a couple fewer bits of rockets floating around up there to be collision hazards or explosion hazards. That said, there's still pieces that remain up there, whether it's pieces of the rocket if it's a higher altitude launch or the satellite itself. And what's interesting to me about this new push towards reuse is that it's not the first time we've tried this. Space Shuttle initially was intended to be fully reusable. It was not, for multiple reasons, which I don't think we should get into right now. But in the 70s and really the 60s through the 80s, NASA attempted to move towards sort of refashioning outer space into a reusable infrastructure, one in which we didn't just use throwaway rockets and once a satellite breaks, you leave it up there until it falls back to Earth, if it falls back at all. Instead, they were hoping that creating a reusable space shuttle, which would serve as a kind of garbage truck and servicing vehicle, also in conjunction with an orbiting, with some space stations that could be used as repair depots, but also satellites that were designed from the beginning to be retrieved, refueled, and repaired and redeployed. So there's 3 R's in there, but there's actually 4 R's. But instead of reduce, reuse, recycle, it's retrieve, repair, redeploy. And the hope was that by doing this, it would make the space industry, it would basically lower costs for operating in space, which was the main reason. But it had the ancillary effect of also keeping space a little more clear. You're not just leaving things up there until fate sends them somewhere. So that said, it's very, it takes a lot of investment to kind of change something when it's already in motion. And that said, there were a couple of satellites that were designed to be 3R'd. The most famous being Hubble, the Hubble Space Telescope, was designed to be retrieved and repaired. And there were several repair missions that took place over the course of the shuttle program, most famously when it originally launched with its primary mirror off balance and had to be repaired and have this sort of contact lens attached to it, so to speak. So if the Hubble had not been initially designed to be repaired, it would have been a complete failure. There would have been no way to fix it. So it was kind of designed to fit in the space shuttle payload bay. It had handholds on board. It was designed to be something that astronauts could go and grapple and work with in microgravity. There were a couple of other satellites that were the same, but each time they tried to retrieve and repair those satellites, it was never something that could be standardized. You had to kind of reinvent the wheel each time. Because when you're working in microgravity, the same forces aren't at play as they are on Earth. There were a couple times when satellites were retrieved or even brought back to Earth, which is great. They could be reused. They could be scrapped. They could be in a museum, which is where pieces of the Hubble currently are. But Hubble itself, now that the space shuttle program is retired, is going to be destroyed. It will eventually re-enter the atmosphere. We cannot boost it anymore unless they develop a new technology to do so. And in fact, in the last servicing mission, they attached a ring to the bottom so that it could be grappled by some future technology and dragged in a controlled fashion back into the atmosphere, so we don't have another Skylab type situation on our hands, where it's falling where we don't know where it's going to fall. So that said, there was the problem of the space shuttle not being fully reusable and being more expensive than expected. There was the fact that it was hard to generalize operating procedures on how to reuse and repair satellites. There was the fact that not everyone was on board in standardizing when you have multiple actors at play. But then there was also the risk. The Challenger accident happened around the same time that NASA was trying to test out satellite reuse and repair. And ultimately the risk to astronauts' lives was deemed too high.
Who's repairing it?
Right. Ultimately, it's better to just have a single-use satellite than to risk astronauts' lives repairing those satellites.
It was a bitter cold but sparkling clear morning at Cape Canaveral. Here, the last seconds of the countdown.
3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
It happened just over 1 minute into flight.
1 minute, 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles.
From mission control, silence. Then the bland, chilling report.
We have a report from the flight dynamics officer that the vehicle has exploded. We are looking at to see what can be done at this point.
A search effort couldn't begin for some 15 minutes after this. Debris, they said, just kept raining from the sky.
What's interesting to me is, so now we have these reusable rockets that come back to Earth and can be flown multiple times, which is reducing the amount of debris, and presumably also eventually reducing the cost, which has always been what's behind it all along. But they're just talking about the launch vehicles. The rest of the infrastructure is still single use. So ultimately, there's one component that's being taken out of the equation, but the others are still there and that are increasing. I mean, SpaceX is building however many reusable rockets, but they're putting up hundreds of new satellites, hundreds and thousands of new satellites. So really, it's kind of 6 of one, half dozen of the other. I mean, it's good not to have rocket bodies in space because they have fuel on board and can explode. But
sure,
this is not the solution to the problem by any stretch.
Right.
The sole solution to the problem, and that's not what this was. The larger, a broader kind of ethos of reuse was something that the NASA of the 60s through 80s was considering as a way to kind of really more fully address the issue, but that's not something that I think that current space powers have a real sense of. And that I'm also hoping, that having this historical background will maybe open that box a little and make it clear that these are the considerations that went into it in the past, then so we don't, constantly keep running into the same issues.
That we've maybe hit on the same solution, but for a totally different ethos. So not an environmental awareness necessarily, but a practicality, cost effectiveness.
Oh, it was that too in an earlier era, but it's really more a matter of scope. SpaceX and its ilk are more concerned about just the launch vehicle, not the satellites themselves. So yes, it's reducing waste and reducing costs for launches, but by exponentially increasing the total number of objects that stay in orbit and that could eventually re-enter, it's still exponentially raising the risk.
Right. Because it's the three. It's reduce, reuse, recycle. So they're doing the reuse and recycle, but it's not really a reduction.
But only
in any meaningful sense.
That's sort of like only if you're recycling glass jars, but all of your aluminum is just being thrown into the water. Right. But the launch vehicle is very visible. It's something that's exciting. We all get to see it happening. We don't see the satellites as visibly as we do the launch vehicles. They're very charismatic. They're fun to watch, and anyone can. So them coming back to Earth and landing, it's something that's very easy to celebrate. But I think we've just become so used to satellites just being single use, and once they die, they're done. That it's not. This isn't part of the current discussion, and I kind of wish it was.
So how much discussion is there around space junk? I mean, do people know about and care about this idea? Because I think you've demonstrated that there are human costs and there are definitely human concerns and environmental concerns and around this. But how much is this getting airtime or attention?
It tends to get a lot of attention when there's a crisis. Now, there hasn't been a crisis yet in a way that has had an actual material outcome for users on the ground. So one of the first really big accidental collision in orbit happened in 2009 when a functioning Iridium communication satellite and a non-functioning piece of Russian debris collided head-on over Siberia, destroyed both, created two pretty big plumes of debris clustered along their orbital paths. But the Iridium satellite is part of a constellation, much like Starlink, so any outages were picked up by other satellites in the constellation. There hasn't been any kind of real problem where a lot of people are experiencing an interruption to their daily technological practices. Once that happens, there may be more attention paid towards what's happening in outer space. But whenever big things re-enter, there's kind of a big flashpoint, people tend to pay attention. Or, for example, when astronomers make news and agitate the way they did for Westford, the way they did for Starlink, that's when the space debris issue becomes more visible to a general public. But it's something that I think it's a perennial topic, and there are a lot of both state space agencies and startups that are coming up with ideas for how to remove space junk, which is called remediation. And there's also been some discussion on how to mitigation. So how to create less debris so that there's less to clean up. And there's currently no legally binding rules for how to deal with space debris, but it's something that's kind of constantly in motion and kind of like up to the really good faith efforts of those who have the power to reach space and to operate in space to try to keep it clean so that they can continue to operate, so that others can continue to operate safely. But we're kind of at a really interesting moment of shifting of who's in power and also just materially how much stuff is up there. We're kind of at a really important moment. And it'll be really interesting, I think, to see. I'm a historian. I don't really feel like I can really predict what's going to happen. But I think in the coming years, this is going to be something that the conversation is going to have to shift in order to prevent kind of a major space junk crisis from happening.
I think it might have been inconceivable that an individual or an individual company would have, at the very beginning of these debates, was there a perception that it would only be governments or, large space agencies that were directing traffic into space, so to speak? Was there a concept that there would be like an individual or an individual company that was sending up material into space?
I mean, for the most part, during the early space age and during most of the Cold War, states were the only entities that had that kind of capital or those kind of resources to have a space program. But as we kind of move into this new Gilded Age, where we have these billionaires who have their vanity space programs. Jeff Bezos has his own space program. Elon Musk has a space program. They all have their own space programs, and this is something where suddenly individuals can have capital on the same level, if not more, than a state space program, than a taxpayer-funded space program. I think it would have been inconceivable because that kind of wealth disparity was not quite something that was conceivable then. At least during that kind of that height of the Cold War, when when NASA and the Soviet space program were at their height, America holds this very high value on entrepreneurs, on better, higher, faster, and the idea of bureaucracy and red tape those are dirty words, right?
Right. Like why would we want to stop these nice, young, excited people from absolutely filling our orbit with tiny bits of broken plastic and metal? Why would we ever want to stop them or get in their way?
But you have to. But one of the things that's so interesting about it is, well, when you have bureaucracy and red tape, you have safeguards. You have enough people approving or examining a project to make sure that it will be safe, and that is something that astronomers worked on establishing and actually did end up getting codified in the Outer Space Treaty. That international consultation of scientists had to be undertaken before any state could launch a space project that could pollute or contaminate outer space. But again, as the actors are changing, as we're having startups going up that don't have the same oversight, and that even when they are subject to oversight, don't always comply.
It is a little scary because what you're describing, what some people label bureaucracy and red tape, is really process. It's saying that there is a process by which we choose to put things up into the atmosphere or not, and hopefully more than shareholders get consulted during that, more than the designers and the shareholders get consulted in that process. Hopefully, if it's a good, healthy process, then a lot of different groups of people and interested people and experts are going to be, affected communities, constituencies are going to be part of that process. You hope, like that's the goal. Right. That's the actual goal of a red tape bureaucratic process, is not to withhold progress or something. It's for all the people, the affected parties, to have a chance to weigh in and say, here's an angle that might not be considered by someone who has this great idea.
So, for instance, I think another good example of the opposite of that is that SpaceX launched that cherry red Tesla with a mannequin on board a couple of years ago.
Amazing pictures from space. Elon Musk pulls off an engineering feat. He sent his own kind of rocket man on board a Tesla Roadster into orbit. Elon Musk has outdone himself this time.
That is not something that a state space program would do, because they are beholden to the taxpayers. They are beholden to representatives who would likely, it would not have been that blatant kind of dummy payload. There would have been many more considerations going into what you would use that test launch to do.
Right.
Beyond basically a glorified advertisement for one of the company, for another company owned by Elon Musk, right?
Right.
It was this kind of vertical integration between Tesla and SpaceX. It was just capitalism on full glorious display, without much checks and balances.
Well, I hope all the interested parties will read your book. I really hope so. Before all of our satellites go down and we're stuck refreshing our phones over and over and over and over for information that's not going to come. So thank you so much. This is really fascinating, and I'm a little bit scared, which I think is healthy.
Well, it's my pleasure. Don't be too scared. I think we're still okay, but we still need to be aware, right? That's the kind of, with any sort of environmental crisis, if we see it coming, you need to be aware so that it doesn't reach that tipping point. The tipping point that we've reached in multiple other environmental crises. We want to try to prevent that from happening. So awareness is the first step.
Thanks for listening to this episode of Distillations. Remember, Distillations is more than a podcast. It's also a multimedia magazine. You can find our videos, stories, and every single podcast episode at distillations.org. And you'll also find podcast transcripts and show notes. You can follow the Science History Institute on Facebook, Twitter, and Instagram for news and updates about the podcast and everything else going on in our museum, library, and Center for Research. This episode was produced by Mariel Carr and Rigo Hernandez, and it was mixed by James Morrison. The Science History Institute remains committed to revealing the role of science in our world. Please support our efforts at sciencehistory.org/givenow. For Distillations, I'm Lisa Berry Drago. Thanks for listening.